Imagine a world bigger than Jupiter, hiding in plain sight for over a decade. Astronomers had its image in their archives, but never realized it was there. This is the story of Beta Pictoris d, a planet overlooked because we were searching for a bright dot, not a hidden pattern. For years our telescopes gathered data, but our assumptions blinded us. The universe doesn't reveal its secrets easily, it hides them in patterns we haven't learned to see. Beta Pictoris d's discovery is a lesson in changing perspective. Sometimes the next breakthrough isn't about building a bigger telescope, but about asking a new question. Instead of searching for a planet's light, scientists looked for its chemical fingerprint. That shift revealed a world that was always there. Our astronomical archives may be filled with unseen planets, treasures waiting for us to notice. This isn't just an astronomical success, it's a humbling reminder. The greatest discoveries might be hidden in data we already have. Beta Pictoris d challenges us to look deeper, not just farther. How many other worlds have we missed? The universe rewards curiosity and fresh eyes. Sometimes, the ghost in the machine is only waiting for us to listen differently, and when we do, entire new worlds can appear. To find Beta Pictoris d, we travel 63 light-years to the young star Beta Pictoris. This star, just 20 million years old, is surrounded by a swirling disk of gas and dust, a planetary nursery. Decades ago, astronomers first imaged this debris disk, a sign that planets were forming. The disk's warps and gaps hinted at hidden worlds shaping its structure. In 2008, astronomers directly imaged Beta Pictoris b, a massive gas giant. Later, Planet C was found closer in, using the star's wobble. With two giants confirmed, the system became a laboratory for planet formation. Yet, the disk's pattern suggested something more, another planet influencing the dust. The gravity of planets B and C couldn't explain all the features. Scientists suspected a third planet, but old methods couldn't find it. The clues were there, but the search needed a new approach. Beta Pictoris was a puzzle with a missing piece. The stage was set for a new kind of discovery. The old ways had reached their limit. It was time to look at the system with fresh eyes. Most exoplanets are found indirectly, by a star's dimming or wobble. These methods reveal a planet's presence but not its image. Direct imaging is the holy grail, but stars outshine their planets by billions of times. Astronomers use coronagraphs to block starlight, searching for faint dots. That's how Beta Pictoris b was found. For years, scientists scoured images for more dots, without success. Beta Pictoris d remained invisible, lost in the glare and dust. The problem? It was too close to the star and too faint to appear as a dot. The traditional search failed because the planet didn't play by the rules. Its signal was buried in noise. To find it, astronomers had to stop looking for a dot and start listening for a chemical signature. They needed a new way to perceive the universe. The hunt for hidden worlds demanded a radical shift, and that shift would change everything. The breakthrough came with spectroscopy, splitting light into its component colors to reveal chemical fingerprints. Instead of searching for a bright spot, astronomers looked for the unique signature of a planet's atmosphere. Using the James Webb Space Telescope, they hunted for molecules like methane and carbon monoxide. These molecules absorb light at specific infrared wavelengths, creating a chemical shadow. This approach filtered out the star's glare and the disk's glow. By focusing on the planet's spectral barcode, everything else faded away. The team applied this technique to 11 years of archived data. Suddenly a clear signal emerged, a moving source with the right chemical fingerprint. It wasn't a dot, but a pattern. The ghost planet finally appeared. Spectroscopy turned noise into discovery. The universe had been hiding a world in plain sight. All it took was asking a new question. The discovery of Beta Pictoris d was electrifying. Its position matched predictions from the disk's structure, exactly where a planet should be. Tracking its motion over 11 years confirmed it orbited the star, not just a background object. The clincher was its chemical fingerprint, a perfect match for a gas giant's atmosphere. Position, motion, and chemistry combined to prove its existence. Beta Pictoris d was no longer a theory, but a reality. This discovery showed that planets can hide in plain sight, invisible to traditional methods. Every planet's atmosphere has a unique spectral barcode. By learning to read these barcodes, we can find worlds otherwise lost in the glare. Beta Pictoris d is the first planet discovered this way, a trailblazer for future searches. It proved we don't just have to look for planets, we can listen for their chemical songs. The invisible became visible. A new era of exoplanet hunting had begun. What is Beta Pictoris d like? It's a super Jupiter, 8 times Jupiter's mass but only slightly larger in size, making it incredibly dense. It orbits its star at 2.7 astronomical units, much closer than Jupiter is to our Sun. The planet is hot, with a turbulent atmosphere rich in carbon monoxide, water vapor, and methane. There's no surface, just crushing pressure and searing heat. Life as we know it couldn't exist here. Comparing Beta Pictoris d to its siblings, planets B and C, gives us a unique laboratory. Each planet is different in mass, orbit, and composition. Studying them reveals how planetary systems form and evolve. Why are these worlds so different? The Beta Pictoris system holds clues to the diversity of planets in our galaxy. It's a cosmic laboratory for understanding how worlds are born. The discovery of Beta Pictoris d is more than just adding a planet to our list. It's a paradigm shift, showing that our archives may hold countless hidden worlds. New discoveries don't always require new telescopes, but new ways of looking at old data. The right question can unlock secrets buried for years. Future telescopes will combine imaging and spectroscopy, searching for atmospheric barcodes and even signs of life. The hunt for planets is just beginning. Many more worlds like Beta Pictoris d are waiting in the glare, detectable by their chemical voices. As we refine these techniques, we'll uncover new populations of planets. The night sky is filled with secrets, streaming down in data. Somewhere in those archives, a planet hid for 11 years. What else is waiting to be found? We may already have the data, we just need to learn how to see it. The cosmos is waiting for us to ask the right question.